All right, so this is lesson 21, 3.1b, number 1. So we're trying to find dy dx by implicit differentiation. So the good thing about implicit differentiation is that you don't have to solve for y. Okay, so solving for y a lot of time is difficult, okay, and sometimes impossible. So in this case, then we want to use implicit differentiation. So the first step, there are 2 steps in implicit differentiation. The first step is going to differentiate both sides with respect to x. So let's do that. So differentiate the left side with respect to x. Differentiate the right side with respect to x also. Okay. Now, and then the second step will be solving for dy dx. So this is the first step. Now, when we do this, differentiate the left side here with respect to x here. You see here, this is a product of 2 functions because you think about this, this is a multiplication. Okay. So y, think about that as the first function. Cosine x, think about it as the second function. So it's a product of 2 functions. So to differentiate that, we use the product rule. So using the product rule, what do we get? Can you tell me? F times g, when you differentiate the product of f times g, you get f prime times g plus f times g prime. The order I do it, I like to do it this way because for me, it seems like whichever comes first, I want to differentiate first and times the second one, plus now write down the first one, differentiate the second one. So kind of like first come, first serve when you do differentiation here. So over here, we're going to differentiate the first function y with respect to x. So we end up with dy dx. Okay. And then we're going to times the second function, which is cosine x. And then adding. Now the first function we just copy, which is just y. Now we're going to differentiate the second function. Differentiate cosine x over here. Okay. So we're using the product rule. So let's just leave it like this on the left side. Now do the right side here. The right side over here, to differentiate this is the sum of, think about it as a sum of 2 functions. So we're going to differentiate the first function, adding the derivative of the second function with respect to x. So when we differentiate this function here with respect to x, what do we get? We get 3, right? This constant multiple is 3. And then times the derivative of x squared with respect to x. And then this one here, similarly, we're going to differentiate this. So the 4 is a constant multiple. So we have the 4 outside. And then we're going to differentiate y squared with respect to x. So far, okay?
Yeah.
Okay. Now, I write down every step. Okay, so just in case I miss anything. So, okay, now here we have dy dx. Okay. Let's write this as y prime. That might be easier that way. So y prime. So I don't have to put. And then times cosine x. And then adding y times the derivative of cosine x with respect to x is what? Negative.
Yeah, negative sine x.
Sine x. Yes, you got it. Now here on the right side, I have 3. And the derivative of x squared with respect to x. What's the derivative of x squared with respect to x?
2x.
Yeah, so we got 2x here. Plus, now we have the 4 here. Now, be careful here. You see here, the y squared here, it looks very simple. However, is a composite of 2 functions. The outer function is a square function. The square function is the outer one. The inner function here is the y. Y is a function of x. This is a function of x. Okay, so when we differentiate a composite of function, we have to use the chain rule here. So chain rule. Okay, so we're going to use the chain rule. For this part right here. Okay.
So it would be 2y times y prime, right?
You got it. Okay, good job. So that will be 2y and then times y prime. Okay, so that we're done with first step. We could simplify this a little bit. And then the second step here will be to solve for y prime. So to solve for y prime here, I see that looks like this one has y prime, and then this one also has y prime. Let's put them together on one side. So let's put them on the left side and take out the common factor y prime. And then we will have cosine x minus 8y. Okay. And then on the right side, we'll have 6x. And then we're going to have this one move it over, become plus y times sine x. Now to solve for y prime over here, all we have to do is divide both sides by this. So we'll have 6x plus y times sine x divided by cosine x minus 8y. So that's y prime. So the problem over here, oh yes, it check. Okay. So y times sine x plus 6x and divide by cosine x minus 8y. Yeah, it's the same answer here.
Okay.
Which part you got stuck?
I think on the part on the right above the second step, I think I forgot to incorporate the y prime times cosine x on the left side.
Oh, okay. Oh yeah, it's a product. It's a product of 2 functions, y and cosine x. Yeah. But you remember the chain rule well. That's great.
Yeah, I think because when I was I did the product rule, but